So yeah, such an inspiring story, and yeah, I think AI is really changing the way we do many things, especially software development. So I've been really interested into seeing what AI allows, not just in software development. So my area of focus is using AI when building applications, so inside my application. And of course, I also use AI to help me build, but I want to understand how can I use AI inside my application. And the idea today is to show how you can build an agent and how you can move from a prototype to production, what are the problems that you need to solve, what's important to take care. And I'll focus on two different products. One is Strands Agents, that is a completely open source framework that we shared just around when we had the other user group meeting. I think it was June or maybe May. And then Amazon Bedrock AgentCore, that is a tool that allows you to move and run agent in production in an easier way, something that is still in preview. We launched it in July, and we're now going towards general availability. So the idea is that when we start using AI models, and this is probably last year, we were using it in this way. You know, we were passing a prompt to a model inside our application, and we're getting a response. And the problem was how to prepare the right prompt for the model. And this was called prompt engineering at the time, and there were lots of ideas, suggestions, articles, and there was a lot of improvement. Clearly, over time, we wanted to start to go a little bit farther away. And we want to say, okay, let's not have just a single interaction, let's have a conversation like you have now with these chat applications. So in this case, the response, you need to include it in the prompt. So when you use any chat application, what happens under the hood is that the response of the model is added, so there is an append to the prompt, so you have all the iteration of your conversation, the next question, and this is passed to the model that provides a response. And clearly this starts to fill up this context window more, because now you have the full history of the conversation, so much more space. The size of the context windows was in the thousands of tokens. A token is a word or part of a word. But now we are reaching hundreds of thousands, and we have many models that start to have 1 million of tokens of context window. So you can put probably 10 books inside this context window all at once. So it's a lot if it's only text, not so much if you start to mix up other modality like images or videos. But definitely context is a scarce resource. And probably in the current stage of AI, when we build AI application and when we use AI application, the main bottleneck is the context, how we use the context and the size of the context. If you used, like Diana, a software development tool recently, probably you've seen that at some point this model is taking a lot of information from your file system with workspace and functionality like that, and it fills up the context, and it will start to do something that is either called summarization or compacting. It's trying to optimize and remove content from the prompt, from the context. And normally you also see a degradation of performance because the summarization is not as good as the original content. And that's something that we will try to address today, and we'll see at the end some possible solutions. So what happens today is that models can be used as agents. So it all started with a paper in 2023 called React, Reason and Act. And the idea was that if I send some information, we now call it context, to a model, there is a request here, like tell me which library to use for creating, for getting a list of words in English. The model can also decide to use tools. So in this context, there is a description of the tools that the models can use, like maybe there's access to a dictionary, there's access to a web search, so it can do a web search to get more information. And this is a tool. And at some point, the model can call one or more tools and can generate the final response, and then the response again is generating some sort of update of the context that is not only an append like before, but it's really an update. We're trying to optimize the context. To give you an idea of how this works, this is starting to get into the models themselves. Like in the last update of Claude Sonnet 4.5, they now have a functionality where they can remove, based on some configuration, the tool responses. This is because normally in the size of the context, a lot of space is taken from the responses from the tool. Imagine tools that maybe go on a file system, read files and send back information from these files, or maybe images and content like that. So the model itself has some functionality to optimize and remove, for example, the responses from the tool. So it's difficult to change the context because normally models are trained in a normal loop. So if you start to change things, you can also confuse the model and then get more hallucinations. So the idea is that we're moving from prompt engineering to context engineering, and this was all the rage on social media a few weeks back. And the idea is that there is this new art. So we need to build applications that work like this, that are at the end agents, and they need to fill the context window with exactly the minimum amount of information that you need. And maybe you can also remove content when it's not needed anymore. And at this point, when you build an agent, you start to do things that look like an operating system. In fact, many people have said that there are some parallels between context engineering and operating system, because you need to do memory management. What is in the memory that is the working memory of the model, storage management. So if you have external information like in a semantic vector database, what to retrieve, what to keep, what to delete in next iterations, use other databases like graphs for knowledge graphs. Also at some point, all this is the classical agentic loop. There's some scheduling like an operating system. So at some point you want to maybe trigger activities that can help you clean up or optimize the context, and we'll see some example of this. I/O becomes the use of tools, and there's process control. Instead of the classical process of an operating system, you have things like defining the task that the model needs to do to complete the request that it has received. Each task then needs to be solved. More recently, many agents have this concept of task management. I think they introduced something similar in Cursor last week. There's something similar in Amazon Q and Kiro. There's something similar with Cloud Code. When you start with a complex request, they start to build a task list, and then they need to fill this task one by one. And multimodal support as well. One area of focus is memory. Memory is the way you preserve information in this loop. And there's a lot of similarity in the language between how memory works for agent and how memory works with humans. Some people like that, some people doesn't like that. I think it's fair because at the end models are trained on human content, on content found on the internet, so it's fair to have similarities. And the recent trend is to create hierarchical memory systems. So the short-term memory is the memory that we keep in the context that is sent to the model every time as a whole. And it's similar to the short memory that we have. We normally remember the few last hours, the last day very well. But then we pass this information to some process that does an asynchronous consolidation of this memory, is extracting the information that we want to preserve. For example, the user preferences, like I want to use a specific library or a specific tool, or maybe I want to extract semantic facts from a longer conversation. And this is stored in a long-term memory that is not passed every time in the context, but is normally stored somewhere, and it's normally used with some vector semantic database. So when you need some information, you go there, similar to the RAG, retrieval augmented generation approach, and you retrieve additional information. And this is very similar to how human memory works, because we have a short-term memory. Normally when we sleep, we have one of the oldest part of the brain, this the hippocampus, that takes this information and transforms this into persistent memories. We lose the details when the memory is stored there. And we know that because people who have problems with the hippocampus, they can't just learn new things. They just don't remember what happened the day before when they wake up. There's a beautiful movie that is now not so recent. It's called Memento. In case you're interested, it's not so happy movie, but it's quite an interesting story built around this idea. So memory consolidation is an approach that is being taken, and the idea is to try to go beyond the classical summarization, and we'll see an implementation of that. Another approach is also state management, and specifically checkpointing and branching. So if you use something for software development, many of these tools, they have the concept of checkpointing. So when they do some big change on your code, they create a checkpoint so that you can go back and roll back if they hallucinate or make changes that you don't want. And you can do the same things with any AI agent. So at some point you want to roll back and maybe try another branch. And this is useful with context. Let's say that this is my initial conversation. Now I send a message, a second message with a reply. At some point, my context is filled up, and optimizing this means that I need to do some summarization. But if I do a summary, I will lose some details. And sometimes this is important for me. So what you can do is that you can do branching. So at some point, you say, OK, after the second message, instead of asking this question, I want to ask a different question. So you take the conversation path and you change it at some point. And this way, you can reuse the same context with a limited set, but you only use the most recent fact. And this is a trick that works very well and helps you to avoid fill the context, especially when the details at the end of the conversation are not important for the other part that you want to cover. So checkpointing and branching is used quite often. So this is a little bit of theory of what we've seen as trends for building AI agents. And then at AWS, we were exploring how to use AI agents in our services. So both in services that use agents explicitly, like Amazon Q Developer or Kiro, but also in other services like AWS Glue that use AI internally to optimize the way they use they work with data. And what we realized that all the frameworks that were built last year, not that it is ages ago for generative AI, they were using a lot of scaffolding with prompts and internal prompts to make the models do what the agent should do. So if you use tools like LangGraph or you use tools like CrewAI, normally they have a lot of scaffolding with internal prompts that tells to the model, you need to do this, you need to follow the instruction in this way. And these internal scaffolding and internal prompts are not necessary anymore with modern models, because modern models are already trained to follow instruction and to follow instruction in an agentic way. And with reasoning, you don't need anymore to use chain of thoughts or this approach, because the models, they natively start to thinking, okay, if you ask me something, I will build a plan to solve this. So what we thought is maybe we should do a completely different approach, because at the time you often need to handle errors yourself, because you need to build sort of state machine where you say, okay, this is the agent, if there is this error, then I call this other agent, or I do these other things. But what if we can let the model take this decision? Models are sophisticated enough to do that. So what we did, we went back to the root and say, okay, let's go back to the React paper that we can read online, and let's do something where we don't want to, an agent frameworks with no scaffolding at all. Let's give freedom to the model. And that's how Strands Agent was built. So Strands Agents is this open source framework that we released, I think May or June. It was very fresh when we met last time. It's now production ready. It reached 1.0 in July. On the same day we launched AgentCore. It's completely open, so it supports models running on AWS, but you can use models running on OpenAI, you can use models running on Gemini. It supports light LLM. Just a couple of days ago, someone on Blue Sky, that is nicer than the other platform, that I will not mention, he reached out to me and shared a video of how he used Strands with Light LLM. Light LLM is an open source library that allows you to use almost any model on the planet to build an agent in very few lines of code. So the idea is, let's do something that is a new approach to agent development. It's model driven. The model drives the activity. There's no workflow, nothing that is forcing the model to do something. We give freedom to the model. And this is, strangely enough, making things more resilient, because if there is an error, and this is now a best practice, at the beginning of the year, like if you get an error from an API or from a tool, the best way is just to report the error back to the model, and hopefully the model will have information to overcome or solve the error, or just report the error back. And also, if the user asks something that is unexpected, this is where probably you get benefit from an agent compared to a rule-based solution. You can take out and explore different paths, because the model will try to do something that you couldn't plan when you developed the agent. And this is the idea of the flow of Strands Agents. That is very simple. So if the user sends a prompt to the agent, the agent passes the prompt to the model returns back something of a plan that can involve calling one or more tools, then the response is sent back to the model, and at some point the model will tell, okay, this is the final answer, and can be sent back. So very, very simple. There's no internal prompting, so updating or changing model, it's much easier, and there are no bottlenecks on the model itself. So if you use Strands Agents, this is the very simple quick start. So it's in Python currently. We're exploring support for other languages. So install the library, and this is the hello world. So you import from the Strands library agent, and then you can create an agent. So this is an agent with no system prompt, nothing. It's just the raw model. By default, it's using Claude Sonnet, I think now 4, but you can use virtually any model available, like OpenAI, Gemini, or it also supports Olama to run models locally in case you want. And then you can ask the agent something, like tell me about agentic AI, and the model in this case will use the knowledge of the model. The agent will use the knowledge of the model to send me a response. Very, very simple. Next step is that we can add tools. So there's a bunch of internal tools that we provide, like calculator. Now AI models are not very good with mathematics, so calculator, the possibility to read and optionally also write files in a specific folder that you provide, and also to run shell commands inside that folder. And then we can create an agent, and now we pass a list of tools. So this agent has no system prompt again. You can specify system prompt if you want, but it has access to a calculator, can read files in the folder that I can configure, and can run shell commands. And now I can ask something like, what is 42 to the 9th? And it will tell me that it's using hopefully the calculator tool, and I can also tell me the contents of a specific file in this directory. It will read it and tell me maybe a summary of the content of the file. Very direct, very few lines of code, and you can create an agent. How can we scale this? Well, more recently, I mentioned one of the bottlenecks is the context size of an agent, of the model. So how can we split the context? We can create more agents. And maybe have one agent do a specific part of what I need, and another agent do other things. Now, the classical example is what is called the deep research scenarios, where you maybe have an agent that is researching content online, another agent maybe has access to enterprise or a specific content that you have through another API, and maybe then you have someone that collects all this information, and then you have finally a technical writer that will consolidate and create the output document. This works for a few reasons, because you're splitting the context, but you need to be careful that the agents don't send back too much information. Otherwise, if you give work to an agent and then the agent tells back a lot of stuff, then you're just filling up the original context again. So you need to be careful about that. And also the number of tools that an agent can use is still limited with the models that we have today. So normally when I say a tool, it's not a clear definition, but for example, if you give an agent access to a browser, so a browser tool, a browser normally has between 10 and 20 functions, like you have a function that the model can use to click on a specific part of a page, another function tells the model to navigate to a page, another function tells to the model to take a snapshot of a page, another function to enter text in a text box, and so on. So you normally have between 10 and 20 functions. So this is the number of tools. Currently, models work well when they don't have more than 30, 40, sometimes let's say 30, 40 tools When they get more of 30, 40 tools, they start to get confused because all the tool description is in the context. So the model will have a description of all the tools, all the syntax of all the tools, and they start to not use all the tools in a great way. So splitting the context, splitting the tools is a great way to scale a problem. So multi-agents is something that is being explored. And to build multi-agents, there are a few approaches that I would like to show how they work with Strands. So one way that's probably the simplest is to use is the pattern of using agents as tools. So instead of giving my agent access to the web browser that has 12 different actions, I create an agent that is a web browser agent that has access to these 12 tools. And then my initial agent, I tell them, if you need to browse something, ask this agent, so one function, what to do and what you need to return. So I only add one tool to my initial agent, and the other agent has visibility to all the low-level tools. Then if I need to have access to maybe an enterprise system like a CRM, again, I create a CRM agent that has access to all the functionality of my CRM, or maybe a subset if there are too many, and then I can say to my initial agent, if you need something from the CRM to read or to update the CRM, ask this agent with this single function. So it's a way to simplify things. Another approach that is more similar to what I described at the beginning is graphs. So many tools like LangGraph, for example, you define multi-agents as with a graph, like each graph is a node is an agent, and then you say, no, there is a web researcher agent, and then gives the result to someone else, and so on. So static, but of course effective for specific use cases. Or you can create a swarm. A swarm is something that is more like an autonomous collaboration of agents. So you can create multiple agents and have some way where they can share the information. So instead of having the context separated per agent, you have a sort of shared space where that is sent to all the context of all the agents, and they can share information and they can work together better. And then there's the meta agents, that is the approach of creating agents that can create other agents. And we will arrive to that. So agents as tools. This is how you can build them with Strands. So in Strands you can create a tool. We saw before the predefined tools like the calculator. If you want to create a tool, you can use, in Python is called the decorator, at tool. And then you can define a function. So this function will become a tool that you can pass to an agent. So in this case it's the research analyst. In this case, the research analyst function, the tool, is actually creating a research agent and asking the agent the request that was sent in input to the function. So this function is actually creating an agent, asking the agent a question, and getting the response back. So this is the research analyst. This is the travel advisor that you can, again, is creating an agent that is planning. This agent has also access to tools. So this one has access to the web search and the calculator. This one to an hypothetical flight search tool, hotel search tool, hypothetical, but then you can find probably this kind of tools available for almost any website now, and then return the answer. And then you can create your main agent, that is the executive assistant in this case, that has tools as the research analyst and the travel advisor. So it's calling these two functions that then are creating and using the agents. In this case, every time you invoke an sorry, yeah.
Is it not confusing? You have tools as agents and tools as functions as well. And how does this collaborate with the MCP server as an orchestrator?
So in this case, there's no MCP. If you, for example, with Strands, I didn't include the code, but with Strands, you have access to an MCP client, and you create an MCP client that can connect to an MCP server. And in that case, the MCP server, in its own description, will export all the functions like this. They will then be mapped to the agent, and then you can pass them. Basically, the MCP client as a method that return this list, so that instead of having an hard-coded list like this here, you basically say get all the tools from this client, from this MCP client. But yeah, it is confusing, but I think it's important to clarify this agent as tools because it's a main pattern, and we're starting to use it that when you do software development, you're using these kind of things without knowing. So the tool is actually an agent. In this case, the agents are declared inside the function for simplicity. So it means that this agent is created, responds, and then it's destroyed. Optionally, you can put the agent outside of the function, and then if the research analyst is called multiple times, the agent will keep the history of the conversation. Depending on the use case, you might want something fire and forget, or you might want something that preserves the history of the interactions. Probably in this scenario, I would probably preserve the list of the interactions, but it's up to you. So this is the first approach that we can use. And yeah,
it looks like a pattern, like a progression. Parts are deterministic.
Yeah, we're starting to have this kind of development pattern for AI, and they're absolutely not deterministic. So testing is all another. In fact, when you start to have these dynamic architectures, the better word is evaluation. So how do you want to evaluate? And currently, the best approach to evaluate this agent is to use an LLM as judge. So basically, because they're so dynamic, you use another LLM as judge to see if the result is correct. With different approach, because clearly if you just do it blindly, you might have hallucination on testing, but there are strategies also for that. So agents as tools. The second approach is the graph. That is similar to what you do with tools like LangGraph. So in Strands, you create a graph builder, and then you can add nodes to the graph. Each node is an agent, so the researcher, the analyst, and the writer that you defined similar to before. And then you can connect the nodes, so the agent adding an edge. So the researcher will send the result to the analyst, and then the analyst will send the result to the writer of the report. So in this case, it's a very linear graph, but you can also have nodes that can have conditions, and you can have something more dynamic. But it's a directed graph at the end. So this is very static, but works well for some scenarios. Swarms is a little bit trickier. You can create swarms like this, so you create multiple agents like a researcher, an analyst, and a writer, and then you can say create a team that is a swarm of these three agents, and what happens is that these three agents will automatically share their context, part of their context. In this way, when the researcher responds back, all the other agents will see the result. And the flow here is not deterministic, so these agents have their own description, so the swarm will decide, okay, let's start based on the problem, and the researcher should start first, but it's not deterministic. Then probably will intervene to see to check the result, and the writer will take the final result to write the report, but it's defined by how you describe the job of the agents, and the model will decide what to use. Probably in this case, it's an absolute overkill, but in some cases, like when you go to software development, could be something interesting. And finally, the meta agents, so the most exotic things. In Strands, these things that we saw, so the graph, the swarm, and also the use agent as tools, can be passed as tools themselves. So basically here I'm creating an agent where I'm saying you are an agent. Your system prompt tells you can dynamically create specialized agents and orchestrate their workflow. And to do so, you have access to these tools. So you can create a graph of agents where you define the nodes, you define the description, you define everything that we saw before. You can create a swarm if you want. You can use an agent as tool. So this is a tool that allows you to use an agent as tool without the tool notation. You can create a workflow that is similar to the graph but linear. So what I showed before was actually more of work. And then the think tool is a tool that allows, gives access to a scratchpad to the model so that the model can think more and take notes and look back to the notes because they are trained to do that. Yeah?
That's a question. You talk about the swarm that by the end you created a team, right?
Yes.
Can I say that that team is like an umbrella of agents that act as an agent?
Yeah, that's definitely one way to see it. It's like a team of people working together, because the idea is that these agents, they have a shared space where they share information. So you don't need to explicitly tell this agent give the results to that other, but they have a shared space of information where they can share data. But yeah, it's an umbrella, and at some point you can also think of this as an agent.
Sorry, just on the questions, we're going to have some food coming soon, and we can. Are you going to stay after your talk?
Yeah. Okay.
Do you mind picking questions up after? Sure.
Okay.
Thank you.
Okay. Sorry. And so this is the meta agent, and we can create other agents. So we've seen how complex this can become with very few lines of code. So this is 6 lines of code that can create dynamically agents with different architecture and stuff. It's incredibly powerful. The problem is that if you build these kind of things, it's very easy to build a prototype, show the prototype inside your companies, everybody's happy, but then you need to move it in production, and then take these 5 lines of code with no user authentication, no user identity, no security, permissions, nobody checks the permission of what an agent can do, then move it in production can be complex. So for this reason, we launched AgentCore, and AgentCore has this component. So as a runtime to run your agents. Sorry, I didn't realize that this was animated, but I'll go back. So a runtime where you can run agents, and that's the concept of session. So every session runs on a separate serverless environment, like a Lambda function, but can run up to 8 hours. Then there's an identity service to handle identities inbound and outbound. Then there is other tools that I will show, a gateway for MCP servers, memory that we briefly saw how it works, and then 2 tools to have access to a browser and a code interpreter. And all these tools also use OpenTelemetry for observability, so that you can get a trace of all the interaction within the different agents and the different files. So the runtime is a tool that allows you to take an agent and with very few lines of code launch it into a I really didn't check that it was animated, but it's good because we don't have a lot of time. Run into a container and has this concept of sessions. So if 2 sessions arrive to the same agent, they always run in separate virtual environment. We use in Firecracker like Lambda and Fargate. Identity helps you handle inbound identity into the agent, so authenticate who is entering into the agent, and then you can use that also for outbound identity using IAM, using auth, or using API keys. The gateway can take any Lambda function or any REST endpoint and transform them into an MCP server with all the latest MCP protocol support, and it also has a semantic search, so this is very cool. So let's say that you have a company that has a lot of internal APIs and Lambda functions. You can transform maybe hundreds of them into tools that could be used by agents. Because by definition MCP means that any of these tool will have all the description in human language of what these tools do and how they should be used, because that's what MCP provides. We automatically index this using a semantic vector style database, and then we provide you a hidden tools that start with the underscore that you can use to search semantically your tools. So if you have 300 tools, you can say which tools can help me understand a support case for my customer, and it will use a semantic search to tell you probably these are the top 3 tools that you could use. And in theory, you could use this with the dynamic scenario of before to create dynamically an agent that has access to the best tools for a specific task. So you can go even further what we saw and create dynamically agent that has access to a dynamic subset of tools. Memory, we'll see that in work, but basically supports short-term memory, so basically the conversation, and then it can extract long-term memory, so user preference information, and then you can use in your application. And then the browser tool gives you access to a browser for web search. It works by providing access through a WebSocket, then you can use a library like Playwright to use it. And then a code interpreter is an environment that has a tool that you can use to run Python, JavaScript, and TypeScript code, and it also has access to a local file system. And then finally, observability is based on OpenTelemetry. All these components, and optionally your code, if you instrument it, will send this information to OpenTelemetry. And all these tools can be used together or separately, so you can use only the memory, only the runtime, only the identity, depending on your use case. So we have a few minutes for the demo. So I'm playing a lot with these things. As I said, it's still all preview, so not production ready. And one of the things of AgentCore is designed to be model and framework agnostic. So I created on Dev2 a series of 6 articles where I use AgentCore runtime to run the agent and memory, short and long term, and we'll see what that means, for Strands Agents, but also for QAI, for LangGraph, for Llama Index, and for Pydantic AI, and probably I forgot one. And there is also a repo with all the examples at once. So if you're interested, then I can give you the QR code. The code goes to the repo, I think, and the repo has the link to the articles at the beginning. I also created a memory browser, so it's a very simple web interface to browse a memory, and we'll see how that works live. It's still an article and then in my GitHub repo. And then finally, and we will go to this after, there's some a prototype that I built to build something more advanced of what we provide now for memory. So let's go into the demo. So this is the main repo, the first link, so the repo with the example for QAI, LangGraph, so on. And today I'll focus on Strand Index. So this is the README. So let's follow the README. Let's make this a little bit bigger. I don't want to go full screen and readable. We don't need the AI for the demo. Already help build it. And yeah, the prompt is very long, so we can make this narrow here. Okay. So I normally use UV for managing Python projects. If you don't do it, you should, because it's much better than pip. So it's already synchronized. So the first thing we need to do is create the memory. So I have some scripts here. Let's run this because it takes, so UV run create memory. Okay, my SSO login has expired. I try to be a good person and use single sign-on for my login. Okay. Second factor, and we're in. Okay, now we can run it again. No, not the login. Okay, so this is creating a memory. Let's see at what it actually does. So the create memory will use the AgentCore SDK. That is a sort of thin wrapper on top of the Python SDKs. Makes things a little bit easier, but you can also use the direct SDK if you want. It's creating a memory. So this is where I create the memory and wait for the memory to be ready. It normally takes 2-3 minutes. This is a demo, so probably 5-6 minutes. And this is the memory client. And when you create a memory, by default, it creates the short-term memory, where you can store what we call events. Each event is normally a piece of conversation. But then you can add strategies, and the strategies are defined here. These are actually the default ones. So I create a user preference strategy that will extract user preference from the conversation. If I say, for example, I like this, I dislike that, and if this is a customer, you can use this the next time to avoid making a mistake. And this long-term memory is stored into a vector store that is hierarchical. So the hierarchy is normally something that you define. This is the default that we suggest. So we have /actor, and then the actor ID. The actor ID is how in AgentCore we define the user ID, because in our vision this can be either a user ID or an agent ID. That's why we use the term actor ID. So inside the actor there are the different folders for each actor ID, so user or agent. Then there is a strategy, and then the ID of the strategy. Then we create another, and then I can search at any level of the hierarchy, and that's what makes it easier. So I can search information for a specific actor or for a specific strategy. This is the semantic strategy. It's going to extract semantic facts from a conversation. And because user preference are also semantic facts, you will see that there are overlaps, but this is broader. And here I'm creating a folder for each specific session, so that if I want, I can go back and search only a specific session or the full hierarchy of an actor, of a user. And then here I have the summarization. This will create a summary of each session ID. So I have a summary of each conversation that I can retrieve. And the advantage compared to the raw events is this is indexed, so I can use a semantic search. So now the memory, as we discussed before, is going to take definitely more. But the idea is then we will add a sample memory, and we will use this API to create a sample event that is going to be stored with this create event syntax. So create an event for a memory ID. That is the memory. So each memory ID is a strange terminology, but it's the overall umbrella of the all memories for a specific application, for example. This actor ID, this session ID, and this is the message to store. And in my case, the message to store is I like apples but not bananas. That is actually true, by the way. So the memory has been created. So now I can run the add the memory. So UV run. And this is now sending this single event. I like apples but not bananas. Is this user, and this is the default. So now this is gone. The event has been created, and normally it takes, currently in preview, less than a minute to process this event into a long-term strategy. It's usually okay, but so what we can do is that we can use the AgentCore memory browser to look at the memory. So this is the tool that I mentioned that I built. That is starting with an internal server error, since fitting the demo. So this is now last minute updates. So let's do something slightly different. I have the memory browser here, and let's do. Let's try again, and then if it doesn't work, we can trust the memory to work. Oh, we have something. So here we can choose the memory ID. So the memory, there is only one memory, is the one that we created that took a few minutes. And now here we can list the events if we want. So if I go here, I can say, so the actor was my user ID. And the session was default because I don't manage sessions for them. And in fact, I did it on purpose to show if it works. Basically half of the characters were wrong, and it now found the memory. And if we zoom here, we can see now I like apples. This is exactly the same information that I sent. And now if I go here, I can search for user preferences. I can retrieve. This is the hierarchy. I can just search under slash, so it will search everywhere. So probably not something you would do in production. Sorry, the namespace should be slash. And then here I should put something like fruit. And it's found that there are 3 long-term memory about fruit. One is the user preferences, one is the semantic facts, and one is the session summaries, because they all 3 picked up this single sentence. And if we look at the user preference, for example, it says that the user directly stated a food preference about fruit, likes apple, dislikes banana. Categories, food, fruit, so it enriched the content to be used. Okay, now that the memory is working, what we can do is that we can go back here on the multi-framework and go back into the AgentCore Strands examples, and here we can let's just follow the instruction because improvising live is never good. So the memory has been created, and now we can it's probably here. Is this? No, this is the wrong README. This is the correct one. When we created the memory, created a configuration file, so the memory can be used and shared between LangGraph, CrewAI, Strands, because it's a different concept. And then I can activate the virtual environment explicitly so that I have access to the AgentCore starter toolkit. And here I can use AgentCore to configure this agent. So if I give it a name and where is the file, it's asking me for what permissions, where to create the Docker image, bunch of stuff that I accept the default now, but of course you will probably be much more careful. I can now run the agent locally using Docker locally or other tools like Podman or Finch, or I can use AgentCore launch to deploy the agent. And this is going to take a couple of minutes again. And the interesting thing is that to create an agent, there's a lot of code here but basically you create the agent as we saw. You said that there is a tool to retrieve memories from the long-term memories. Here is where I created the agent, and the agent has some hooks, and these hooks basically will do two things. Automatically the agent, when there is a new message, will store it using the short memory hook as an event, and then it will, when there is any question, it will retrieve, similar to RAG, any information from long-term memories that could be related to that question, and will enrich, augment the prompt with this information. And the code is all here, so in case you're interested. And the interesting part is that basically the only thing you need to do to use AgentCore is that you need to say which function is the entry point for AgentCore, and in this case I just use a decorator, and automatically AgentCore will pass any input that I send, authenticated or in this case non-authenticated because I didn't set up authentication, to this invoke function in the payload with some additional information in the context. So it should be okay. So if we go here, I can call AgentCore status. It should tell me that it's okay. And now if we go back to the README, we can, for example, use AgentCore invoke and pass this prompt that asks what did I say about through it. And if everything works, so this is the first invocation. This is serverless, so it's spinning up the environment. And it's telling us in a previous conversation, you directly stated your food preferences, banana, apples, and so on. So it has used the tools to retrieve that information. So final thing, and then almost on time, we go next. So we seen now how you can use it with many frameworks. We saw how you can explore memory with this graphical tool. The next thing was how can we go beyond this? So there is still the problem of summarization. So I have the summary of the conversation, but if I need the detail, it's lost in the summarization if the detail is important. Not all use cases are so peculiar. So what I did, I took so Strands has the concept of conversation manager, that is the module that is called when the context fills up, and the conversation manager will use some strategy to reduce the context. Normally summarization, delete the old messages that are lost, and then you have the last 10 messages, for example, and the summary of what happened before, and then you can go on. And this is similar to what Cloud Code or Cursor do, and you see the degradation of performance because data is lost. So what I did, I said, let's call it semantic summarizing conversation manager, and what it does is like this. So when the user asks a question, this goes to a hook that I said is a trigger that will look into the semantic index if there is something saved. What I do is that when there is summarization, I save all the old messages into an in-memory structure, because 1 million of tokens is a lot for a model, but it's peanuts for the RAM of a computer. So you can store it in memory. You have gigabytes. And then I also have a semantic index that can use either a local embedding model or an Amazon Bedrock embedding model that will index. So when I ask a question, I say, is there any old message that I archived that is related to this question? If yes, it will return specific messages. I will compute a radius, so I will not only take the specific message, but there is a parameter that by default is 2, also the 2 message before and after, so that you get a little bit of context around the message. And then I enrich the input information with something like, hey, from the previous conversation, we also discuss this. So not in skyrocketing, but in my experience, this works very well, because even after summarization, you have the full story, but you can also get any specific detail. And this is just a prototype. It's here on GitHub. I still have to write an article about that. And if you want to see how it works, let's go here to Kiro. And you just need to do uv run main to run it. And here we have the stored output, because I knew that I would have been late by the time. So this is the output that is already appearing there. So first I test the local embeddings, but it's the same if you use... basically I send this kind of information. There are a lot of messages. And I start with by saying this. Let's make this a little bit bigger. This is also for tense. I said we have a shared reference number for this conversation that is, and this is a random number that is generated every time, 624. Keep this number for our records, but don't include it in any summary. If I ask for the shared number later and I say the word pineapple, then you're authorized to tell me back the number. All of this because modern models are trained to not tell secrets. So without the secret word, it wouldn't tell me the secrets even if it worked. And if you use the word secret instead of secret reference number, it will never tell you the number again, because models are trained to not say secrets. So this is the initial conversation. Then I have some random stuff that talks about data structures, Python, arrays, and stuff. And this is 20 lines of conversation. And then I configure summarization to be very fast. So instead of 1 megabyte after 20 is triggered, it creates a summary, and it is indexing all the conversation. So this is the summary, where, of course, the number is not included, because I told them not include this number in the summary. So we're talking about data structures, array. There's completely no mention of that initial part of the conversation in the summary. And then there are the last few 5 conversation, 6, 8 pieces of conversation that are preserved. And then I ask, what was our shared number? Please tell me the exact number. The word is pineapple. If I add secret word, it will not tell, because secret is triggers security, and say no, and they will never mention it. And then if we go here, we see that we get that the number has been returned. And here we can see that actually this is what has been added to the conversation based on a previous conversation. This earlier exchange may be relevant to our current question, and there is the message about the 624 secret number with the 2, each item of conversation is assistant user added after, and nothing before, because it was the first message. So it worked. So without this tool, you wouldn't get the secret number. Of course, this is a fake scenario to test it, but if you're doing software development, you can retrieve any specific thing that you said in the past, even if it's lost in the summarization. And with this, I think we can move on to better things. Thank you. I forgot to say there are MCP servers that you can connect to your development environment, both for Strands and for AgentCore. So if you configure these MCP servers, they will help you develop with Strands and stuff.
So do
Thank
those MCP servers provide documentation? And
It's been a
references
a
or
very self-referencing
actual tools?
implementation.
Yeah.